Yep, friends, let's go live. All right, let's get the ball rolling. Okay, we got this question right here. The question says a diameter of a circle has an endpoint P, which is AB, and Q, CD. Okay, the question says let Z with a coordinate XY be any other point on the circle. Write down the size of the angle PZQ and the B pair is a hence proof that the equation of the circle can be written as x minus a into bracket multiplying x minus c into bracket plus y minus b into bracket and y minus d into bracket is equal to 0. Now let's see how we went about it. Okay, so as you can see, straight on, this is our circle and a pinkish thing. Then how we have located all the points as it says. As you can see on the left, we got a point AB. Oh man, friends, have a look at it. You see, so this is a point P here, which is AB, and we got a point Q, which is C and D. You got it? So everything is in place, and we chose here to be Z, because when you draw a line from this point to this point, okay, and from the point C to Z, then that would be an intersection. Okay, demarcated as Y. We got X, comma Y here as a coordinate. So definitely, you see, the PZQ is 90 degrees. You got it. So that angle over there is 90 degrees. Well, we can decide to choose any line. Okay, like for instance, when we choose a line, let's see what we can choose. Let's take this line. Okay, when we draw a line here, I'm going to go back to it. All right, let's take any line here. Come on. Okay, let's see. Take this line. Red, for instance. Okay, so we have this line. Choose this line here. So we'll draw a line from here to this point, you see, as we get to this point, from P. Okay, then we'll go back and draw another line here. Okay, from this point to intersect with this point. This is still going to be 90 degrees. Okay, so that is an evidence that a point PZQ is 90 degrees. All right, with that, let's go back and see what we can say. So now when we look at the diagram, we know that we can find the gradient of the line PZ. So PZ here, the gradient of the line will be considering the coordinates of A and B and the coordinate XY. Then our gradient of the line PZ will be Y minus B over X minus A. In the same way, if we got gradient of the line QZ, see this one here? All right, you see, and that will be Y minus D and X minus C. Now, since we know PZ and QZ is perpendicular, the product of their gradients will give us -1. That is something we know all the time. The two gradients, when you multiply them, should give you -1. So now we'll put the respective coordinate that we deduce. So we'll multiply the two of them, like that here, and that is going to give us -1. Fantastic. After that, we do our normal expansion. We cross multiple. So there's whole product here multiplying -1. We got this. Okay, there it is. Now after that, we shift this in here. So this one will be X minus A and X minus C is equal to 0. Hence the proof. Yeah, guys, this is where we finish. Okay, so I'm going to see you again. This is the best way we can go about it. Okay, if you want me to take you through once more, let's go back to it again. So we know the question says what? It's a diameter of a circle, has a point P, which is A, B, that's the coordinate, and Q, C, D is the coordinate. And then let Z to be X, Y, be any other point on the circle. So write down the size of the angle P is a Q. So it's a hence proof that the equation of the circle can be written as that. Okay, so let's go, this is our diagram. we have point P, A, comma B, Q, comma, that is C, comma D. And when we intersect this line in green, we got Z, that will be X, Y. The same way, if we have this line, red line going through this one, and this one going that, the angle PZQ is 90 degrees. Okay, so that is the proof. Now, let's find the gradient of the line PZ. And that with this coordinate AB and this coordinate XY. When we find the gradient, we're going to get Y minus B over X minus A. Now, we also look at this gradient on the right, which is Q, and the Z. We are going to get, yeah, that one, we call that gradient M2, that will be Y minus D over X minus C. Now, for sure, we know that PZ and QZ are perpendicular. So meaning when we multiply their gradient, M1 here, and M2 should give us -1. That is the order of the day. So the M1 times M2 gives us -1. And after that, we put them together. The products should give us -1. Good. Then what do? We do simplification. So all this expression here, we multiply this -1 here, then we have this expression like that. So what do? We shift this one on the left. So we're going to get X minus B, Y minus D plus X minus A, and X minus C is equals 0. Hence the proof. That's where we come to end. Now, see you guys again.